So, what do we have on the bench today? Well, we got a pair of these. So I must have liked the price on these. I got 2 of them. So let's see if they're what they're cracked up to be. Alright, so this is, I'm not sure you can see it there. 5 volts at rated for 5 volts, 2 amps. So this is model ARUSB-2A. Good for 100 to 240 volts, 50 or 60 hertz. 5 volts, 2 amps, of course, made in China. Let's see, that's kind of a low. So no agency approvals. But it claims to be doubly insulated. Yes, we'll see about that. So I don't feel any screws under there. Looks like it has some tabs there, so this must be the one screw holding it. Actually, before we let's break it open. See if there's any reason for us to be afraid. Alright, so those are rather thin, but don't need much of that. Somebody's carved a 4. Well, the backwards 4. So, looks like the mold is a little on the rough side that they did plastic in. Let's see. This comes out. Let's see. Is it discharged? Yeah, it's discharged. That'll make you safety nuts go crazy. Let's see what we got here. Kind of a minimal. This is basically the bare minimum here. We got an indicating LED. That's rather nice. A pair of capacitors here. So we have the blue caps. See if I can get some magnification here. Well, it looks like the capacitor may have the right credentials. Of course, they're calling it that is actually not a cap, that's an MOV. Well, that's a surprise. I guess this... Yeah, that's a resistor ouch. Well, that dug in. So I think that's a resistor pretending to be a fuse. Wow. So this is a DK112. That's the switch mode controller. We got 2 diodes here on our output. Of course, this is a single output. 10 volt caps. Claims to be low ESR. This is kind of wobbly. No cold solder. Looks like they used a, you can see glue around the components. They used some glue dots to hold the components to the board. I'm guessing they wave soldered this. Not too good a quality. Look at that bead right there. Looks like they had to touch up the solder in quite a few places. So our caps, trying to find a voltage on them. So they're 10 microfarads. At 400 volts. Let's see. For the US, that's perfectly fine. 240 volt line though, and we're still within the 400 volts, even if it's a 240 volt main. All right, so let's see if we can look that chip up. DK112. All right, let's see what I can find. Looks like this is found an application note. So we have here. So let's see. So we got our fuse, which in this case I am pretty sure that's a resistor. Just from the shape of it. Let's see if we can nibble that back a little bit and see for sure. Oh yeah, there we go. Definitely a resistor. Wow. All right. Well, a resistor is cheaper than a fuse. So we have the MOV, which honestly, it's marked as MOV on the board. That's not an MOV. That's a capacitor. I marked it as if it was an MOV. And then here's our capacitor here. Can't see really any of the markings. They're very faint. So we don't know if this is one of those self-healings or not. It's the right color, right general shape, but it's hard to tell. Alright, so kind of moving on through here. What we got? Alright. So let's show that. Alright, so this, okay, so you can see that's our main capacitor. That's these two guys here, which appear to be in I thought they were in parallel. So on the output of that, we go through an inductor to the next one. Oh, that's interesting. Inductor to there. This schematic is kind of an example out of their application note, which is rather interesting. There's some differences in this one here, difference over what we have here. One difference is, well, this is a 10 microfarad capacitor. Let's check a quick pic. Squeeze it and see if yeah, clearly a 10. So that's a 10 microfarad. Primary difference between this board and this circuit, for whatever reason, at this point here, they come in and add, coming off of the C2, they add an inductor, and then they have another 400 volt cap. And this is also 10 micro. And then this goes into the circuitry. And it looks like the chip drives the transformer. That is interesting. So we got our chip ground. This is the feedback. Of course, we have the two capacitors here, these two 10 volt capacitors. Let's see, what is the, oh, this is a 12 volt output. So this one is built around 12 volts. We have this additional common mode choke here. That's on the output. That's a little bit more filtering. Let's see. They paralleled the diodes to get the. Or did they? Wait a minute. No. Yeah, those are paralleled. How's that going to work? So it looks like. Yeah, it looks like indeed they did parallel them. Those are connected here, connected here. And then there's a resistor here, and a capacitor. Provides probably a little filtering. So there should be a Zener diode somewhere. Most likely on this side. Not far from the opto. This is, I already guessed this is the Zener. This provides the feedback to the chip for the 5 volts, or well, in this case 5 volts, and the Zener would set that voltage rating. Interesting thing with this, they've got a very cheap surge, well, yeah, it's interesting they did this, because this limits the voltage differential, because this can actually arc through. It's kind of a cheap way of doing some surge suppression or transient suppression. It's just interesting it's across from the line side of the power supply and the low voltage side. That's interesting. I would have expected to see a gap there. I think overall this is an okay power supply, although I would like to have seen a UL rating or an SA rating, some agency approval other than the CE. CE just is really kind of the low-hanging fruit when it comes to any certifications. But at least they're being honest. Well, we're assuming they're being honest. We don't know if they actually have the paperwork the European Union requires for CE. Let's own this out. This doesn't make sense. So let's get our ohm meter in here. Well, actually, we're going to do diode check. There's diode check. Alright, blocks in one polarity. conducts in this polarity. Or does it? Well, it's charging up. Interesting. So let's try this again. Okay, there we go. Alright, so these diodes are paralleled. And clearly, so that goes that way. Oh, okay. Yes, I see what they've done now. Yes, they're very clearly paralleled. Here's the cathode line here. That leads over to here. This is the anode side. The cathode line is right up against the board where that lead pushes through. So yes, they are indeed correct. So let's put this together, see if it still works. Yeah. Well, no, it's not going to work. I broke it. Let's fix that real quick. Sorry. There we go. Alright, so what do we have for a soldered filter? Right, I'm not supposed to be doing repairs up here. Oh well. Let's move the meter out before it becomes covered in solder and melted. Oh, that came right out. I'll just stick the lead through. Alright, hole looks big enough. There we go. Ah, shucks. Pulled it right out. Try again. It's like threading a needle sometimes. Alright. Do I have my... No, I do not have the helping hands up here. Alright, so... do our solder. Yeah, that's not pretty. Let me fold it over a little bit. Get it to stay. There we go. Well, let's see. Yeah, it's not very thick wire. But it'll be good enough for 2 amps. Excuse me. Been a bit of a respiratory bug going around. Alright. Alrighty, so we're going to do that. We're going to tuck that back in like that. Alright, so. Alright, let's get some things out of the bench here. Alright. Alright. Get that way. Put the screw back in. Alrighty then. Screws in, back together, nice and proper. LEDs in place. Alright. Please don't blow up. Alright. Green light came on. There we go. Green light's on. Excuse me. Alright. Plug it into my handy little tester here. Alright. Let's see what we got. Ooh, this thing's a little hot. 5.44. That's a wee bit high. Let's see. So it comes down to 5.24 at 1 amp. Two amps. Let's see. What point do we drop below 5? We drop below 5 at... Oops, too much. Here we go. Let's call it... I'm having a little trouble. Alright, let's call it at 2.21 amps. It's still at 5 volts. So let's see. And there she went. So it almost got to 3 before it shut down. Oh, it did get to 3. Looks like a 3.1. She bites it. That's not bad. That's. I mean, this is rated for 2 amps. We're up to 3. It's pretty good before it drops out. But of course, it's. I'd stay within the rating that it's stamped for. So that's actually pretty good. I'm a little concerned about the 4 point being 5.44. So let's check the other one real quick. Of course, I'm trusting the this thing here being calibrated, which we know it hasn't. All right, so let's see what we got here. All right, so 5.44. So let's see. Wonder if I can measure. Or if this will let me put a meter there. I haven't been using this particular tester very long. I need to send in and get a replacement. This one has the backlight doesn't work. Although that may be partly my fault. Alright. No, 5.40. That's what my meter is doing. So that's spot on. So Again, this is the second one. Let's see if we can get, so 5.44. See if we can get 2 amps out of it. There's 2 amps. 2.25. We're right at 5. I'm at 3 amps. 4.87 volts. And there she goes. So 2.97 at 4.9. Again, that's decent. I still don't like the 5.44, but it doesn't take long. It doesn't take much current before it loads down. It gets down to 5.25. So that's, if you're using like TTL and you're using that standard, 5.5 is the absolute max. So that should work out fine. So this is an okay power supply. Again, not happy about it not having any agency approvals. But build seems a little okay, not great. You can see there's a lot of dull solder joints. Appears that they wave solder it, which there's absolutely nothing wrong with doing that. But this, the quality of the wave soldering didn't look all that great. Yeah. The wire going through this cable was copper in color. I didn't look any further than that. So that's it. That's the review of the ARUSB-2A. Another one of those kind of no-name power supplies. Nice thing about this one is it has a LED.